Hi, I'm Juyeon, and welcome to the presentation for our paper, Stochastic Conditional Diffusion Models for Robust Semantic Image Synthesis. Semantic Image Synthesis, or SIS, is a task to generate realistic images from semantic maps or labels. It can be formulated as approximating the conditional distribution Qx given y, where x and y are the random variables denoting the image and the semantic map respectively. SIS has a wide range of practical applications such as photo editing or content creation. However, one significant challenge in real-world applications is dealing with noisy input from users. For instance, users might mark specific areas they wish to edit or create using a computer mouse or their fingers. These marks often contain errors such as jagged edges or incompletely marked areas. Typically, models are trained on clean labels from the dataset, but during inference, the input labels are often noisy. This discrepancy leads to poor performance, highlighting a gap between the label distributions for training and inference. We address this problem by introducing a novel conditional diffusion model called Stochastic Conditional Diffusion Model, or SCDM. Our model, which is trained with clean labels from datasets, can generate high-quality images even when given noisy labels by users. The key difference between typical conditional diffusion models and ours is label diffusion, a discrete diffusion process for the labels. Label diffusion gradually erases the information from time 0 to t by masking or by utilizing an observing state. Label diffusion makes the intermediate noisy maps and clean maps gradually become similar as they are masked and eventually become identical. As the trajectories of clean and noisy labels provided to the model during the generation process are similar, the generated image is close to the clean image, thereby enhancing robustness against noisy inputs. The forward and generation processes of a CDM are as follows. Another important aspect of a CDM is a class-wise noise schedule. We observe that the semantic information of small or rare objects in an image is prone to be lost or hard to learn due to the quick masking of their labels compared to larger or more common objects. Therefore, we propose a class-wise noise schedule to differentially transform labels depending on the class. In other words, we slowly mask small or rare objects by introducing terms regarding the object size and the frequency of the classes. Here, gamma is the probability that a semantic label C has been assigned to the observing state until time step t, and we adjust this gamma to define the class-wise noise schedule. We introduce a new SIS benchmark designed to assess generation performance under noisy conditions, simulating human errors that can occur during real-world applications. There are 3 experimental setups. DS employs downsampled semantic maps, simulating human errors like jagged edges and coarse or low-resolution user inputs. Edge masks the edges of instances with an unlabeled class, imitating incomplete annotations around edges, especially between instances. Random randomly adds an unlabeled class to the semantic maps, simulating unintended user error and extreme random noise. Our CDM demonstrates superior robustness to all 3 types of noise in generation quality measured by FID compared to other baselines. In addition, the generation results given clean and noisy labels are similar, while without label diffusion, the results show inconsistency. In conclusion, our paper addresses a significant challenge in semantic image synthesis by proposing a robust solution that handles noisy user inputs effectively. We propose a novel conditional diffusion model called SCDM, specifically designed to enhance robustness on noisy labels. Additionally, we present a new benchmark setting to assess performance under noisy conditions. SCDM successfully improves generation quality through its label diffusion and class-wise noise schedule. And this is the end of our presentation. For more details and interesting theoretical analysis, please visit our paper via the link in the description box. Thanks for watching.